Well, thank you for inviting me to the event. It's great to be back at another OpenNebula conference once again. So welcome to my talk about bringing your own VLANs to the cloud with QinQ. So OpenNebula gained QinQ support for Open vSwitch QinQ feature since OpenNebula 6.2.2, but can be easily backported to older versions if need be, like we did to version 5.12. You do need OVS 2.8 and up, and Linux kernel 4.9 or higher, or a kernel which has these features backported. Why use QinQ? You can use it to transparently connect two separate networks. In this example, a customer with this switch connected to a cloud provider, and transparently bring the VLANs, in this case, available to the virtual machines running on the cloud provider side. From a customer perspective, nothing special is needed, no special configuration on the switch, it's just an ordinary patch. And from the cloud provider perspective, the only thing that is needed is a special configuration and a VLAN. And the benefit for the provider is that it only costs one VLAN. The alternative would be that the cloud provider would need to allocate as many VLANs the customer wants to use inside its cloud as the customer wants to use, and this might not be possible, desirable, or it might even not be possible at all because the VLAN IDs could potentially clash, and in this case you have to resort to VLAN rewriting, which is a thing you would like to avoid because it can cause a lot of confusion. QinQ can be a solution to this problem in layer 2 environments. Use cases. It allows for hybrid setups where you want to maintain layer 2 connectivity. And hybrid in this sense means physical co-located hardware at the data center, possibly at the cloud provider data center, and a cloud provider. And an example could be that you want to use a physical database with, for example, special local storage, low latency NVMe storage, licenses running on it, compliance reasons, or a combination of both. Specifications that are not met within the cloud provider specifications, but you do want to use virtual machines at the cloud provider. For example, a web farm making use of this database server. Another use case can be that a tenant wants to migrate to the cloud provider and slowly migrate virtual machines from one cloud to the other while maintaining layer 2 connectivity. Or maybe he wants to use the cloud provider to burst when extra resources are needed. What is QinQ exactly? It has its own specification called 802.1ad. Well, you can basically think of it as a VLAN on top of another VLAN. And to show that in some more detail, this figure shows 3 different Ethernet frames. And on top there's an Ethernet frame without a VLAN header, not VLAN aware. In the middle there's an Ethernet frame with one VLAN header, and on the bottom there is a Ethernet frame with 2 VLAN headers. And this is a so-called QinQ frame, or a double-tagged frame. And the VLAN on the outside is called as VLAN, and the VLAN on the inside is called the CVLAN. So basically you can think of QinQ as having two separate types of VLANs. The SVLAN, or service provider VLAN, is used by the service provider to wrap the VLANs of the customer, called CVLANs, inside the Ethernet frame and transport it through its network. So you can think of it as a tunnel, although strictly speaking it isn't a tunnel, because the MAC addresses of both are still preserved and observed by the switches involved, but the end result looks the same. The benefit is that in this case the cloud provider only needs one VLAN, and the customer can use the full VLAN spectrum of up to 4096 VLANs. Another way of saying is like this could be seen as a cloud patch. So we've got the same figure again, but then in somewhat more detail. The black line is the uplink, and in this case VLANs 20, 30 and 100 are tagged to it. The patch is connected to the cloud provider switch. In this case it's a single link, but this can be a bonded interface, a port channel comprising up to as many links as you want, but the principle is the same. And on the cloud provider switch, this port is put into is configured as an access port and put in a .1Q tunnel mode. And in this case the service VLAN used is 666, and the customer VLANs 20, 30 and 100 are wrapped inside, get transported to the hypervisors in the cloud, and the hypervisors with Open vSwitch running on top of them are configured in such a way that the virtual ports of the virtual machines running inside the cloud are made QinQ aware, also put in a .1Q tunnel mode, and the VLANs of the customer are left intact and handed over to the virtual machines running inside. So the VMs in this case have to be VLAN aware, because the traffic is tagged with the VLANs of the customer. So how does this look like in an OpenNebula virtual network configuration? So here's a snippet from Sunstone. In this case there's a bridge called QinQ test, and there are some extra attributes added to this driver in this case, and one of them is called CVLANs, which are the customer VLANs, and this can be changed by the customer, and it can be a list of VLANs or even a range or a combination, like in this case. The VLAN ID in this context is the service provider VLAN, so this is configured by a cloud administrator, and as a VLAN is normally a restricted attribute in OpenNebula, at least by default, normally a cloud provider and a cloud admin can change that. But the customer is allowed to configure its own VLANs inside of it. Do note the MTU of 9000. The MTU has to be at least 1504 bytes to accommodate for the extra 4 bytes overhead of the extra QinQ tag, and in this case is configured as a jumbo frame. If you want to use virtual drivers for Windows and use QinQ, then you can do so. But you can use only one VLAN at a certain time. And you can choose a VLAN by going to the Ethernet properties of the adapter and choose the attribute VLAN ID, and then you can pick one VLAN. If you want to use more than one VLAN inside Windows while using virtual drivers, you would need to add extra network adapters and expose a VLAN in each of them. Details matter, and I will come to that in a second. What we see here is a detailed overview of a virtual Ethernet port on an Open vSwitch bridge. And there are a few things of interest here. On the bottom, there's this thing called VLAN mode. And in this case, it's configured as a .1Q tunnel, just like a switch port had to be put in this stack. Then there's another attribute called CVLANs, and in this case only VLAN number 10 is configured. And then there's a thing called other config in Open vSwitch, which indicates what ether type is used. And by default, OpenNebula uses 802.1q as the ether type for this driver. And this matters because the switch expects the ether type to be of a certain type, and if it doesn't match what it expects it to be, then it might drop the frame. And if you have multiple VLANs published on an uplink or a bridge in Open vSwitch with this special QinQ service VLAN, just one of them, then the port is probably configured to be a trunk port with a bunch of VLANs. Then the ether type of 802.1q is normally what you want, and you don't have to change anything. But if you would have a case that one specific bridge is configured to pass QinQ traffic, then you might have to change that to 802.1 AD to make it work. Well, I would like to thank OpenNebula Systems for implementing this feature. It can be a really useful feature to use, especially if you have not any VXLAN implemented in the network, but you still want to tunnel traffic through your network, through your existing network. So this can be a really useful feature. There's some useful resources. OpenNebula has documentation written about QinQ, which you can find over here. And if you want more in-depth knowledge about how Open vSwitch is configured and what kind of things are done in the background to make this all work, and what parameters you can tweak and tune, you can look up this blog post. Well, thanks. It's all what I had for now, and have a great conference.